So, example. So given this function, x to the 2/3 times 1 minus x. Okay, so the question is, first, find all the critical points. And their types. You get a state, it's an interval of monotonicity. Okay, so let's do this one. Let's find the derivative. Okay. This particular example is that it has some rational power. So we'll see what this rational power has to do with. Okay, so let's compute the derivative. So derivative of x to the 2/3. So 2/3 x to the negative 1/3 times 1 over x minus x plus x to the 2/3 derivative of this 1 minus x, which is just -1. So this gives you, yeah. Okay, so how we deal with this one? All right, so let's do some factorization here. Okay, let's factor out. Okay, what you need to factor out, you see there are two factors here. So you can say this is, let me write this down in different color, power 0. Okay, so this is just one actually. All right, so you have two factors. So you do some factorizations. Let's see, what do we need to factor? I will factor x to the, choose the lowest one. Okay, x, the lowest factor is, this is -1/3, this is 2/3, so it is 1/3. Factor with the lowest. I would factor also this 1/3. So the rest is just in here, the constant. Okay. So what's left? What's left is just 2 times what else? Just 1. And what is this one? Because this is 3. Okay. And then what's supposed to be here? You factor this out, and what's left is just 3x. There. Multiply this out. You get -1 and x power 1, -1/3, and power 1. So you get this 2 things. And if you simplify, this gives you what is 2 minus 2 minus 5. And of course, you can write this down as and so this determine when f prime is 0, meaning the numerator is 0. So this determine the stationary. So when it is derivative doesn't exist, that means the denominator is 0. Okay. So then this happens if x equals, let's see, 2/5, because this is 0. And this is equals 0. All right. And you can say this is defined for all x, all real numbers. This. So what we have now is a uh, we need to consider these 2 points, right? So the second is all right. So let's write this on here. So stationary points at x equals 2/5 and singular at x equals 0. Okay. All right. And then sign chart. So we need to indicate 0 and 2/5. Oh, I should mention that also. No endpoints. Okay, so let's see here. Check the sign here. If you check the sign, you should get this is negative because this one negative here. That's negative. Okay. So between crossing 2/5, this is power 1. So you gotta change the oops. I should this whole here. Okay. Why? Because this is singular. It's not defined. Okay. And crossing 0, this is power 1/3. Okay. Power 1/3. This is has both odd, so it changes sign. Okay. So what you have here is that okay. So this gives you going down, going up, and going down. Okay. And because this is a continuous functions, so you ought to be able to connect these two. So how's the connection here? So it should be something like this. It should be, well, because they're singular, it should be something like, okay. And it keeps going down while here keeps going up there. Going there. Okay. So by change of sign, uh, say changes. So this would be, this give you local max. This give you local. Okay, so there isn't any, uh, no absolute max nor min. Okay, this keeps going down. Let's go back. Okay, so that's what we can say about this one. Questions? Okay, let's do one more example. Oh, I'm sorry, I have to state the monotonically increasing on, let's see. All right, so 0, 50, increasing on left to 0 and from the to 5th. Okay, so that's how to deal with this power. Power 2/3 has to do with this computation because it will introduce a singular point. Right? Another example. Let here x be x minus 1 over x squared. Of course, the domain won't include 0. Everything except 0. And it is continuous on its domain. Okay. And it's also differentiable on its domain. Okay, so let's same question as the example one. Example one. Okay, so what we need to first is to find the critical points. That means find the derivative. Okay, the derivative on the numerator, the derivative is 1. So just take there is the and the derivative of the denominator 2x times this. That's by square of the denominator, so power 4. Okay, we can simplify this a little bit. So this is and factor as much as possible. Let's see. X squared is minus 2x squared, so minus x squared. And then you have also, this is just negative 2x. So you have uh, minus x here. 2. Okay, so you can simplify this a little bit. Now, x minus 2, sorry, there. Okay, and so you see that this will determine we call stationary. This determines the singular. Okay. All right. So like this. Stationary at x equals -2. Okay. Singular. Well, the thing is, I would say from here is singular is 0, but 0 is not on the domain. It is not in the domain. Okay. Therefore, no singular point. Okay. Endpoint and no endpoints either. Okay, so we have this. All right, what about monotonicity? So we need, so you need to find the sign chart, or let's indicate it is not on the domain, but we still need to indicate this one. So 0 and -2. And here you have whole. Okay. So the sign here is that, well, this is negative here, so it's become negative. Across zero is power 3, right? So it's with change sign. Across -2, it's power 1, so it gains sign also. Okay. Okay, one more thing is that from, from F, we know that this supposedly there is a vertical asymptotes at 0 here. Okay. So we just denote by this one, supposedly. All right, so what we can say is that, well, there's a going up and, sorry, going down and up. So this tells you this going to give you a local min. So although here you have a change of sign from plus to minus, you don't have that local max. No, because this is undefined. So there's no local max. Okay. So what we can say is that G is, sorry, this is G, or function is G. Linearly decreasing on, let's see, 2 and increasing on, okay, let's give you the answer of this. Sorry, there's local min. and no local max. Questions? All right, so you see that the um, local min or local max can be determined using only the sign chart. Okay, so you don't need second derivative to find the local min and local max. Questions? No questions? All right, let's continue with the what we call concavity. Okay, so we would like to find out what uh, the sign for second derivative has to do with the shape of the graph. What the sign of second derivative has to do with the shape of the graph. Okay, so that's the question. All right, so let's find the second derivative. So assume the second derivative exists. So assume now second derivative exists. Okay, so what it has to do? All right, so let's see. Um, so, so we have f prime, f double prime. Okay, we know that the f prime positive, it does tells you that the f is increasing. F prime negative tells you that f is decreasing. F increasing. Negative decreasing. So this is theorem B. Okay. All right. So let's say this is equals to, say this is a function g. So second derivative is actually derivative of g. Okay. So the same thing with the g. So if g prime is positive, means g is increasing. G prime is negative means g is decreasing. All right. So, but again, remember, recall that g is actually f prime. This is f double prime. Okay. So what's the has to do with the graph? All right. So all right. So name here. Second derivative positive is that what we call concave up. Okay. negative, this is what we call concave down. Okay, so let's see what it has to do with the graph. All right, let's observe this one, this graph, this shape. Okay, so let's say f is increasing, and with the shape, and okay, so what has to do? Let's find the tangent line. There's tangent line. Okay, so this is tangent lines. Okay, say this is slope, say 1/4. This is slope 1, slope 2, slope 3, slope 4. Okay, so what can you say about the slope? This is positive, right? What about the slope? Because f prime is a slope. What can you say about the slope here? Say this is m 1/4, this is m equals 1, this is m equals 2, m equals 3. So what else can you say about the slope?
The slope gets bigger, sir.
It gets larger and larger. So that's when slope not only positive but increasing. Okay. So functions increasing, that means its derivative is positive. Okay, so the conclusion is that this shape over here is characterized with first derivative positive and second derivative positive. Okay. All right, so let's do something like this. Oh, sorry. Like the red one. Like there. So here we have f is increasing, okay, but with this shape. So because f is increasing, so the first derivative is positive. So okay, so let's do uh, the tangent line thing. Here's tangent, tangent. So if you assign numbers, say this is m equals, say this is 1. This is, say, equals, say, 3/4. This is m equals 1/2, m equals 1/3, m equals there. So what can you say about the slope? One, 3/4, then 1/2, 1/3, 1/4, and then going down. So what about the slope?
So it becomes smaller.
Smaller. So this is decreasing. And a function decreasing means the derivative is negative. Decreasing means that the derivative, okay, which is second derivative, is negative. Okay, So this shape here, characterized by all right. So this is concave up. This is concave down. Okay. Let's do this one here, the shape. So in this case, this is f is decreasing. So it means that f prime is negative. What about the derivative? So the slope again. Slope here. This is slope. So this is m equals, say, this is negative, say, negative 4. This is m negative 2, m negative 1, m negative 1/2, etc. So what can you say about the slope? Slope of tangent line as you're going from left to right. As you move from left to right. From negative 4, negative 2, negative 1, negative 1/2. And so what can you say about slope?
Smaller.
Smaller one. The number looks smaller, but see, this is negative. If you think about the number 4, 2, 1, 1/2, yes, this is gets smaller. But see, this is as negative. So what can you
Bigger,
say
sir.
about slope? This increases. Right? Okay. So increases, that means the derivative of this one, which is second derivative, is positive. It's positive. So this shape here is characterized by, but the second derivative is positive. Okay, so it is still concave up, but with the first derivative. All right, on the other hand, just write directly in this f decreasing. You can check. So decreasing is, but if you check with the second derivative, that's going to be negative also. So to summarize the shape and signs of first and second derivative. Oh, first I would call this, this is only in this course, right? Okay, so this is a plus plus shape because this is first derivative, second derivative. Okay, so this shape is called the, I would say this is plus minus shape. And this is a minus plus. And this one is minus minus shape. Okay. So with this summary, like this, that shape, you have this shape, there are the four shapes. Okay. And what is the sign for the, uh, oh, sorry. I usually write this down as going uh, vertically. So this shape is going down. So this negative, and this concave up. First derivative. This is second derivative. All right. And this one is going up, so increasing. And this is concave down. This one is decreasing, concave, uh, concave down. This one is, let's see, increasing, concave up. Right? So those are the four shapes of the graph. So plus plus, minus minus, minus plus, plus. Okay. Questions? All right. From the last example, we uh, will we'll push for the concavity. Okay, so this problem here, but now we find what is the concavity interval of concave up and concave down. Okay. So let's what we need further. Let's okay. Let's do that one. Okay. So, okay, so what we get here. So G prime is, sorry, keep going up and down. Just want to make a copy of a few things. This is the derivative, first derivative. Okay. Okay, so from here we get a sign chart for G prime. What it tells you about the -2 and 0 here. This is an asymptote. Okay. So we write down the concavity, right? So the sign would be, this is a negative here. Here we have a cross 0. So this change sign, again, change sign again. That's the sign chart. Okay. So we make another sign chart for the second derivative. So let's compute the second derivative. Second derivative is just the derivative of the top. So -1. So we have the cube. Minus derivative of x cubed. So 3 x squared times this one. So become a plus over x to 6. Okay, and let's simplify this. So we have x cubed, 3x cubed. So you have 2x cubed plus 3x squared over x to the 6. And simplify this. Do factorization as much as possible. Don't do cancellations. Okay. So we factor as much as possible. So we have a so 3 2a plus 3. There we go. Now you can cancel here. So we get x in this case. So the sign chart, here you get, of course, here 0. Here you get negative 3/2. Okay. It's going down, up, down. Okay. So this give you the sign chart for G prime. Sorry, G double prime. Let's keep plus across 0, this power 4, so there's no sign G sign. So we can main plus, but 3/2, this is power 1. So G sign. Right, so what you can say, this is concave down, concave up, concave up. Okay. Concave up on concave down on. Yeah. Oh, by the way, I forgot to mention, when you have change of sign for the first derivative, it's called the it gives you the max or min. Right? But when you have change of sign for the second derivative, it's called the inflection point. Okay, so you have, this is inflection point. Okay, so let's in the end, the question is sketch the graph. So what we need here is to find the combined Sign chart. Sign chart for F and F double. Okay. Let's see what numbers should we indicate. So 0, -3.5, -2. Right. So that's 0, -3.5, -2. Okay. So what's the sign? To the right of 0, it is plus here. Sorry, negative, and then positive. So here we have sorry, and between -3.5 to 0, this is positive, this is positive. So positive, positive. Between -2 and -3.5, then this is a small interval here. So positive, negative. All right. And to the left of 2, it is negative, negative. Okay. Recall the shape. This is decreasing, concave up, increasing, concave down, decreasing, concave down, increasing, concave up. All right, so the shape should be minus, 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 minus means that there. And here you go plus, minus. Plus, minus means like this. Plus, minus, is that correct? Something incorrect. Okay, we'll find out. Plus, plus means this, and minus, plus. Okay. I think there's some. So 2, decreasing. Okay, so all right, something strange here. Either we made mistake here. To the left of -2. Sorry, I'll we'll do this later, but let me just finish this one. Just based on this, what we know is that the picture should looks like this one. So 0 here. So this is the it looks like. Okay. And because at 3.5, -3/2, that's inflection. And this should be a stationary. That should be something that looks like this. There. Now this one is there. We'll compute it later. I'll make some revision later. But this is asymptote. Okay. Because this is undefined at here, 0. Okay. Should be this should be like something like this. So this shape should be plus plus here. But what I uh missed something here. Well, we'll redo that one later. Okay. Any questions? If not, then I will stop here. Okay.